Myself, I am Dr. Jntuh. In this class, we are going to discuss about the Unit 4 concept. Unit 4 is about memory management topic. So these are all the contents which we are going to discuss now. First, we are going to discuss about the memory management strategies. After that, swapping concept in the memory, contiguous memory allocation, segmentation, paging, and fragmentation, and various page replacement algorithm, demand paging. So these are all the concepts which we are discussing in the fourth unit. Moving to the first topic, that is memory management. As we know that operating system is a user interface that is capable of interacting a user as well as a hardware. Hence, for this activation of the different types of jobs and tasks, memory is the important component in the computer system. For the every task of the particular user, we have to do with the main memory system. The program which is going to be executed into the system will be loaded into the main memory first. After that, we can capable of executing it. Memory will consist of a different number of words or bytes of data which can be used and stored in the main memory. The program will be loaded into the disk, and after that, it will be placed in a process. Whenever the user is want to fetch that particular program, he can get a particular program from the particular CPU. He fetches the instruction from the main memory. The main memory is comprises of both the registers as well as the storage capacity of a CPU. Every time the main memory can be divided into different types of cycles, which it is classified into CPU registers and the main memory. So these are explained with the help of the diagram. The main memory is divided into a base register and a limit register here. This will define both the logical address space. A base register and a limit register are there in the main memory always. The process of this is to create own process for themselves. The operating system will create a own process for themselves. For example, this is a particular process. This will have a legal address and ensure that the particular legal address is having two types of register. One is a base register, another one is a limit register. The base register will have the smallest legal physical memory, and the limit register does not specify any limit. For example, in this process, there are two numbers are there. So this is a limit of a process. So this limit will restricted to the base register, and this will not having any limit. So it will go for the limit register. Like that, we can classify the base register and the limit register. For example, the minimum number will come under the base register and the maximum number will come under the limit register. Okay, so this is an example for that. So the next topic which we are going to see now is dynamic reallocation of memory. Whether the CPU is capable of allocating the memory to all other objects in the system, it is divided into two categories. One is the logical address and another one is a physical address. For example, if a process that is going to be run with the logical address 346, it is going to enter into the relocation address, where the relocation address is a default one for each and every process. For example, the memory unit will allocate the relocation address. Here, the relocation address of a particular variable is 14,000. Adding this 14,000 to the logical address, we get a physical address for a particular operation. Then the physical address is stored in the main memory function. This is how a logical address is located to the relocation register. After that, it is being linked with the physical address. So the next topic which we are going to discuss now is what is a logical address and what is a physical address space. So logical address is nothing but a CPU is going to generate one of address. So that is other time called as a virtual address. And the physical address is nothing but whether a memory management unit is going to add that particular address, and this address is otherwise called as a memory address register. Both this address will have a compile time, different compile time and a different execution time based upon the address binding method. So both will be having a separate logical address and separate physical address, which depends upon the compilation time and the execution time. So for setting all these type of logical address, we will generate a program that is called as a logical address space. So this will contains both the physical address as well as the logical address. that is being executed in the memory. Coming to the next concept is memory management unit. The memory management unit is nothing but the runtime which is going to be enter into the sequence whether the physical address or a virtual address is there to classify the address based on the hardware device. That is called as a memory management unit. Here, the runtime mapping is a very, very important sequence. We are going to convert the virtual address of a memory to a physical address. This can be done with the help of hardware device, and this device is called as a MMU, that is nothing but memory management unit. So in this, the base registers are used. That type of registers are called as relocation register. The value that is stored in the relocation register is added to every address generated by the user, and it is being mapped. This is what we have seen in the example. So this is a diagram. Here the logical address is every time mapped with the relocation register. After that, it is added to the physical address, and the physical address is being loaded into the main memory. The next concept which we are going to see is the dynamic loading. We know that dynamic means we are going to change our state anywhere doing the operation in the program. Static means we cannot change any type of operation and any values during the execution of a program. Dynamic, we can change at anywhere. So this is a difference between a static and dynamic loading. The dynamic loading is nothing but we can change the memory space of the utilization whenever it is used, and the unused routine may be placed in a separate space. So the main program which is loaded into the memory will allocate the dynamic loading mechanism. So here a buffer will be created, and the buffer will be occupied with a large number of programs. The portion that is used will be very, very small, and the portion which is not used will be remains capped, and it is responsible of a user to design the program and fit into the memory which is used by the particular programmer. So this type of sequence is called as a dynamic loading. So next one is dynamic linking and shared libraries. Dynamic linking is nothing but we are going to use the different type of libraries such as system libraries are linked to the user program whenever it is going to be run inside the system. That is going to be postponed. Dynamic linking is that is to be postponed until the execution of a time of program is defined. Here we are going to take one of a program that is called as a stub. It is a very small piece of code that can capable of execute the appropriate memory and load into the particular library. For example, in a C program, we can say that the header file will be having an extension like that, stdio.h. Here, the extension that is going to be linked with the particular C program is called as .h. Like that, a dynamic linking will be having an extension of a file to implicate and join with the particular library sequence. Dynamic linking is going to connect the two different sequences in an operating system. So the next concept which we are going to discuss is swapping. As we know that swapping is nothing but for exchanging of information between the two number of processes. That is called as a swapping. A process must be takes place in the memory is going to be executed, and it is going to swap the variable, that is swapping of memory between the two different processes. For example, process A and process B is there. Process A is having some of the amount of memory and process B is having some of amount of memory. They can swap their process between A and B. So this is called as swapping. The process of swapping together is called as swapping, and getting out of a main memory function is called as swap out. Okay, so this is called as swapping and swapper. Usually this type of backing store of algorithm is used only in the main memory, because this feature is not supported in the secondary memory because of the limited storage capacity. Whenever we are storing that particular data which is stored in the main memory can be easily retrieved, so that sequence is called as a swapping. In a multi-programming environment, we can use the round-robin sequence and the CPU scheduling algorithm. Each time a quantum has to set that particular value. The memory management here will do two types of operation. One is swapping, another one is swap out. So this will be done on the basis of the priority-based scheduling algorithm. As we know that Priority means whichever the process which are entering into the queue first will be come to serve at first. Whichever the process which are coming at the last sequence will be having the lowest priority sequence that will be served later. Okay, so this process is called as when the higher priority process finish the process. After that, the lower priority will be called upon. So this variant of swapping is called as rolled out and rolled in. Okay, so here we are discussed swap in and swap out as well as the roll in and roll out sequence. So this is an example diagram for a swapping of a process using a database or a disk. Here in the operating system, the user has to make the two different types of process. This can be stored in the main memory that is called as backing store. Two process has been processed here. One is process P1, another one is process P2. That a user is going to store the memory that is called as swap out. When the process is going to retrieve the memory from the database, it is called as swapping. Okay? So the next concept which we are going to see is context switch time. As we know that what is meant by context switch, so the ability of a program that is going to be retrieved from the particular process at a certain interval of time, that is known as a context switch. So this may includes the swapping concept. Now we discuss the swapping. Swapping is nothing but we are going to exchange the process between the two different type of process, okay, by using a backing store. That is nothing but a main memory concept. Normally the backing store is a fast disk because the large amount of memory is going to be stored inside a database. Here, the different copies of memory images and users are going to be provided with the data from the direct access of this different type of devices. Here, the system is going to be in different types of state. As we discussed in the second unit, the process will be having different types of state: ready state, running state, queue state, and waiting state. After that, termination state. Here the system which is going to be in the process of the ready queue will contain all the process those who are having in the main memory, and we can easily retrieve the particular process and execute the process from the particular scheduler. It is called as a dispatcher. The dispatcher is also used to check whether the next process are waiting in the queue or not. Like that, we can check each and every process inside a processing medium. So the next concept is, for example, if we can take that the process of having a memory of 100 milliseconds is going to be performed the operation in 2 seconds. The context switch time here will be a fairly high because the memory size here we have taken is very small. So considerably, the database should reduce the total time of the memory size, and it should perform the particular operation in 1 second. Then it will be called as a context switch. We can reduce the size of a memory by knowing the actual data that is going to be transferred between the host and the medium. We can easily transfer that particular file. So this is called as context switching, including swapping. So this is an example for that one. Okay, so while considering the swapping, we should consider another important parameter that is called as a double buffering. Double buffering is nothing but whenever your overhead is going to be occur in the problem, we are going to add the physical address as well as a logical address to the system. While doing this address binding method, each operation will be wait for the input-output condition to be wait in the method. On the state, each will be facing a buffering condition that is nothing but the process is going to be wait in a queue state, that is called as a buffering condition. The swapping will normally be disabled, and here the started value will be stored to the next sequence. While the swapping is normally disabled and started with a more threshold value, it can capable of disable the particular function and reduce the threshold value with the modified sequence of swapping. This can be used in different types of OS environment. One is a Unix environment, another one is Linux, after that Windows environment. So the next topics which we are going to discuss is swapping concept on the mobile system. As we know that mobile is a handheld devices, we can use swapping easily compared to Windows environment in the mobile system. The main advantage of this is we can frequently reallocate the memory compared to the Windows, but the disadvantage of this process is a space constraint. In the Windows, we will be having in the personal computer, we have a large space, but here we have a very small screen compared to the Windows. The flash memory will be also having the CPU mobile platform to dump the existing code. For example, if a user is opening a 4 application in a mobile, it will get slower. The process will not be simultaneously executed as much faster compared to the Windows. But in the Windows environment, as we know that if we opens the 4 application, it will be support all the 4 application we can run parallelly. So that concept we have discussed in the first unit, that is multi-programming or multitasking. Multitasking is an important feature of a OS that can capable of opening the more number of jobs at a single time, which resides in the main memory. So next one is contiguous memory allocation. During the allocation of a memory in the operating system, as we know that user is going to be allocate the main memory in a process. That process is called as a contiguous memory allocation. Here, one of the resident will be act as a OS and another will be a user process, which we are going to use that particular memory. The memory may be a low memory or it may be a high memory depending upon the process which we are going to select. For example, if I am going to select a large file, I will be having a higher amount of memory. If I am going to select or try or transfer a smaller amount of file, I will be having a smaller amount of memory. So this is how a memory is going to be allocated in the main memory. The next concept is memory mapping and protection. Memory mapping is nothing but we are going to add a address to the existing address. That is, a logical address is going to be converted to the physical address. Like that, we are going to add a logical address to the relocation address. After that, the relocation address will combine both the logical and relocation address to a physical address. Relocation address are usually used to protect the user from the different types of objects that is capable of performing a code and data. Here, the memory management unit will act dynamically to add each value in the relocation address, and it becomes a transient value. So the next topic which we are going to discuss is how the hardware is supporting the relocation concept. Here the CPU is having a logical address. If the condition is yes, and the condition of the logical address is beyond the limit register, it will forward the particular logical address to the relocation register. If it is not yes, if it is the base register, mean it will not proceed that particular logical address. If it is the greater value, it will proceed the function along with the limit register to the relocation register. Here the logical address is added to the relocation relocation register. After that, it is being converted to the physical address and stored in a main memory. So this sequence is called as a relocation by using the limit register. If otherwise, if executed as a true means, this will proceed in a condition. If it is a false condition, it will be having some type of addressing error. It will be moved to the draft status. So next, this is a diagram for the contiguous memory allocation. Contiguous memory allocation is divided into static portion or fixed size partition, or dynamic portion or variable size partition, as we discussed earlier. Static portion, as we know that this portion cannot be changed during the memory allocation. If, for example, the size of a memory file is 100 MB, throughout the process, the size of the file will be remain same as 100 MB. If it is a dynamic partitioning, we can change the size of the file. For example, if it is 100 MB, we can change whenever it is necessary. Variable size partitioning will be allowed in this type of concept. Okay. So the next we are going to discuss with the how the static and dynamic partitioning is going to be done. One of the simplest approach of the allocating members is a fixed size partitioning, that the number of partition is fixed. So it is otherwise called as a static process. Here the multi-programming concept has been used. For example, here all the process will be having a same number of memory capacity, that is 8 MB. So this will be processed while during the internal fragmentation. The process size is limited. We cannot change this process. External fragmentation is allowed in this particular process. So this type of memory is called as static allocation memory. Moving to the next concept, that is variable size partitioning scheme. It is otherwise called as dynamic size memory. Here the partition is free. The process which we select will be having some of the input and it is loaded into the program. Frequently it can change its memory size depending upon the user's application. For example, here there are 5 processors there: P1, P2, P3, P4 and P5. P1 is having the 2 MB file, P2 4 MB, P3 8 MB, P4 10 MB, P5 is 4 MB. What is the advantage here? We can not able to limit the particular number of process. The size of the particular process can also be changed. No internal fragmentation has been used. Okay, so these are all the major advantage of the dynamic allocation memory. So moving to the next one, a memory allocation. As we know that memory is available for all other users, we can use large amount of memory as well as a small amount of memory. In this, a large block of memory is available. It is otherwise called as a whole. The whole can be very large. It can be split into 2 parts. One part is allocated to the arriving process and the other process is returned to the set of holes. Whenever the process is going to be arrived or creating a new one, the system searches for the set of hole whether the particular process is going to be allocated in the particular memory. So this is one type. Second type is when the process is going to be terminating, it releases the block from the particular memory, which is then placed back in the set of holes. If the new hole is very adjacent to the other hole, so these will merge together and form a larger hole in order to avoid the deadlock situation in the system. So this is an important concept in the memory allocation. So the next topic is dynamic storage allocation. What are all the solutions for the dynamic storage allocation? For example, if a memory condition is very good, we can easily store that particular file in a system. If it is not good, we will consider 3 factors for solving this problem: first fit, best fit and worst fit. First fit is nothing but we will allocate the first hole that is very big enough, searching from the set of holes. For example, if a process is having 10 number of holes, we are going to classify the system and identifying the holes as a large, which one is a large hole, and we are taking that particular large hole as a first fit. Second classification is a best fit. Here we are not going to take a large hole, we are going to select a smallest hole which can set to that particular application. For example, here 100 MB file is going to be transferred. We have to use that particular application and select the hole as 100 MB. Here we are having 10 MB, means which will suitable for the 10 MB, we have to select that. Okay, can you know the difference like this? After that, we will be having the worst fit. Worst fit is nothing but if we are having a largest hole or maybe having a smallest hole, the process which we are going to be done will be never fit into the 2 types of holes. It will be automatically come forward out by using the decreasing time. So this is called as a worst fit. Here we cannot take any different type of classification based upon the criteria. For example, so these are the different size of files. Here the process P1 is having 200 file, hence it uses the large fit. Best fit is nothing but, for example, 200 MB fixed size. So we can use the whole as a 200 MB. Worst case, we cannot assign any type of file to this location. Like that, we can classify the best fit, first fit and the worst fit. Okay, moving to the next topic, that is fragmentation. Fragmentation is nothing but we are going to divide a process and allocate a memory considering the size of a memory, whether the particular size of a memory is very small and the other blocks are remains unused. This problem of fragmentation is going to be used, whether we are going to allocate the memory in a fragmentation method, either it may be internal fragmentation or it may be a external fragmentation. What is meant by external fragmentation? External fragmentation is nothing but we are going to use a total memory size to classify the particular memory is a contiguous memory or not. Contiguous is nothing but the memory is going to flow the data in a continuous manner, that is called as a contiguous memory. Okay, both the first fit and the best fit strategies for the memory allocation are going to be used in this external fragmentation. Worst case will become under the internal fragmentation. What is the internal fragmentation? The memory block that is assigned to a process is very much bigger, and the some of the portions of the memory will be not used by that particular application. So that type of method is called as a fragmentation. Okay, one of the solution for the external fragmentation is the compaction. For example, if we want to shuffle the memory, consider a circular queue that 10 blocks are there, but the memory occupied there is 3, remaining 7 remains unused. In that unused part, we can use the compaction method to relocate the dynamic memory. So this type of solution can be applicable for the fragmentation method. By using this technique, so this can be classified into other two methods. One is a paging method, another one is a segmentation method. What is a paging? Paging is a memory management scheme which allows a physical address to move the address space of a process to be a non-contiguous location. Process here allocated will be stored in the main memory, and it will divide the physical memory into fixed blocks of size, and it is called as pages. And the logical memory here will be having blocks of same size, and it is called as a pages. Okay, to run a program, we have to select how many number of page we are going to load into a memory. For example, if we are having 512 bytes, so the size of the 512 bytes in pages is power of 2, and 512 bytes is having a 1 GB per page, and it is being loaded in the form of a pages is called as a paging tool. We can relocate the frame number and the page where it is located, like that we have to give that address. So the next concept is address translation scheme. Here the CPU will always generate a logical address. The logical address generated by the CPU will always contains two types of parts. One is a page number, another one is a page offset. Page number is used to specify whether the specific page of a process from which a CPU whether want to read a data or to index the data to a page table. Page offset is mainly used to specify the particular word on the page that the CPU wants to read the particular data. Page table is nothing but we are going to contain the basic address of the particular page that is into the physical memory. This physical memory address will then send to the memory unit. Thus the page table here will provide both the page number, frame number and page offset value that is required for the physical address. So this is how a address translation scheme is going to be work. So the physical address will contain the both the page offset value and the frame number is used here. The frame number indicate which type of frame, specific frame that the particular page is going to be record and store. Page offset is indicate that a specific word has to be read from that particular page. For example, page number is in the whole number of pages we are having 20. Out of that I am reading first page, like this. Page offset is which type of page we are specifically reading, like that it will mention. So the next one is paging hardware. Here the CPU is going to give a page address for the particular logical address. The page is then moved to the page table, which frame it is going to be used, which frame is used by the particular page table, and the frame is then forwarded to the physical address the page table and the frame offset, and the 3 values are set for each number of page and then loaded to the physical memory. Like this, each page is going to be executed in a model. After that, this is an example for a paging model of having both the logical and physical memory. So this is an example for the logical memory. Here 4 number of pages are there. Here the 4 number of pages will be having 0 value is stored in the page table 1 is stored in 4, 2 is stored in 3, and 3 is stored in 7. After that, each page number will be stored in a physical memory in this corresponding frame number. For example, page number is stored in the value of 1, page 2 is stored in the value of 3. So here we are listed that page 1 is going to be stored in the page frame number of 4, and page 3 is going to be stored in the frame number of 7. Like this, we have to classify that particular method. Another method is that, for example, we can classify the page table with the 4 byte pages concept. Here, the 4 number of pages has been classified depending upon the memory from 0 to 15, that is totally 16. It is equally divided into 4 different parts of logical memory. Here we are going to save the pages in the 4 blocks. For example, 4 is going, frame number is 4, and it is going to have this type of address IJKL. Next, the address is 8, frame number is 8. We are going to store the pages MNOP under the 8. 20 is the number A, B, C, D, like that. 24 is the number E, F, G, H, like that. We are going to store the physical memory inside a 4 byte of addresses. So the next concept is free frames. So free frames is nothing but we are going to free the list of frames and going to do the process in the free frame list. For example, this is a new process. Here we are going to list the 4 number of process along with that existing protocol. For example, here already 4 pages are there. So this process is going to be listed with this free frame list. That is 14, 13, 18, 20, and 15. These 2 will be added to create a free frame list. Here the new process additional to this can be added to the list. So that is called as free frames. For example, page 1 will occur in 13, page 0 will occur in 14, page 2 is 18, page 3 is 20, like that. We can add each and every pages. So the next topic is page table implementation. Here, each operating system in the page table will be having the page table based register. It will point to the particular page table. Page table length register indicates the size of a page table. It is divided into associative memory and TLB. Associative memory is nothing but translation look aside buffer, where we are going to use the special type of retrieval of hardware is called as associative memory. As here we can also be used the ASID, that is address space identifiers, which uniquely access each process to provide the address space protection for that each and every process. So this is a diagram for explaining the page hardware with the TLB. Here the CPU having the logical address will define and store the memory in page number and frame number. After that, the hit value is given for the particular